Why do models get better when we give them a few examples? It really doesn't make sense. Training a model, real learning means updating its weights through gradient descent. But with large language models, we just show them a few examples in a prompt and somehow they get better without any fine tuning, without any weight updates. Most of us just accept that. We call it in-context learning and move on. But some Google researchers stopped to ask, if there's no training happening, why is it still learning? So to investigate, they introduced contextual blocks. It's a simplified abstraction of the transformer's layers to help isolate what's happening during inference. And what they found was mind-blowing. So when you give a prompt, it's behaving as if it applied a tiny targeted update to its internal weights. Not changing any saved parameters, but it's like computing a rank 1 patch that temporarily modifies the network during the forward pass. It's as if the model is quietly fine-tuning itself on the fly. Now, they tested this behavior. They used synthetic tasks where they prompted a model. They gave a model with those derived updates, and they had identical loss curves. So we now have a testable mathematical explanation for how prompting works. That few-shot examples just aren't providing context, they're helping the model adapt to real time. And that's what makes this paper really important. It shows that boundary between training and inference might be thinner than we thought, and that these models aren't static anymore. They're dynamic, they're adapting. And this time, it's not just vibes, it's science.